this video, I'll explain the topic negative superelevation. Also, I'll explain how to solve a problem relating to negative superelevation. So we know what superelevation is. It is the difference in height between the outer rail and the inner rail on a curve. What we do is, we lift the outer rail above the inner rail so that the forces are getting balanced on the curve. Now coming to negative superelevation, when a main line is on a curve and has a turnout of contrary flexure, that means that there is a change in the direction of the curvature. Okay? When there is a change in the direction of curvature leading to a branch line, the superelevation necessary for the average speed of train running over the main line cannot be provided. Okay? So in the figure, what you can see is, there is a main track shown in black ink, and you can see a branch track or branch line which is shown in red ink. Okay? So when you are having the railway track in contrary flexion, now you can see is, here there is a curvature and there is change in curvature for this track. Okay? Now in the main track, this is the outer rail and this is the inner rail. When coming to the branch line, this is the outer rail and this is the inner rail. In figure, AC is the outer rail of the main curve. Okay, that is the main track. You are having the outer rail as AC, which must be higher than inner rail. You know, in order to counteract the effect of centrifugal forces, we provide the superelevation. So, superelevation is provided such that the outer rail is made higher than the inner rail. So as per the figure, you have understood that AC is the outer rail on the main curve, and so because of this, we have to raise the outer rail. That is, point A should be higher than point B. So for this main track, you can see over here, this is the main track. This is the outer track in the main track, and this is the inner rail for the main track. That means A point should be higher than the B point. Clear? Now, when you are coming for the branch line, BF should be higher than AE. Which is the BF line? This is the BF line and this is the AE line. So, as per the branch track, when you are having such a flexure, this is the outer rail and this is the inner rail. Outer rail is to be raised over the inner rail. That means BF rail should be raised than AE rail. Okay? Which implies that point B should be higher than point A. Just before I told you that for the main line, A point should be higher than B point. Now for the branch track, B point should be higher than point A. See here, this is the inner track and this is the outer track. So since this is the outer track, this point should be higher than this point. Now what we can do? These two contradictory conditions cannot be met at the same time. Okay? So for one line, A point should be higher and B point should be lower. When considering the branch line, A point should be lower and B point should be higher. So there are two contradictory conditions and this cannot be met at the same time. So what we do? Instead of outer rail BF on branch line being higher, it is kept lower than AE. That is, what we are going to do is, instead of raising the outer rail on the branch line, we keep it lower than the inner rail. Okay? That is, BF is made, the outer rail BF on the branch line should be made higher, but it is kept lower than AE in such a condition. That means the branch line has a negative superelevation. Actual superelevation is what? We are raising the outer rail over the inner rail, and what we do over here is, when two contradictory conditions come, what we does is, we are lowering the outer rail compared to the inner rail. So this term is known as negative superelevation. Okay? Now when we do this, we have to consider that, or we have to take in mind that the speed on both the track, that is both on the main line as well as on the branch line is to be restricted. So for this, some steps are to be followed. The steps to be followed for working out speed on main line, branch line and super elevation on the branch line, that is negative super elevation on the branch line. So what are the steps to be followed? First one, the equilibrium cant on the branch line is calculated by the formula E is equal to GV square by 1.27 R. The value what you are getting will be in centimeters after assuming a speed on the branch line. So what we have to do is, we know the equation for super elevation is GV square by 1.27 R. We can calculate the value of super elevation, or you can say the cant, after assuming a speed for the branch track. Okay. Then provide the maximum cant deficiency. You have to deduct the cant deficiency from the equilibrium cant. So in the first point I have told you that we have to give a equilibrium cant, or we have to calculate an equilibrium cant. E is equal to GV square by 1.27 R, and we have to deduct the permissible cant deficiency from the equilibrium cant. Now when you are doing this, you will be getting the value for negative super elevation or negative cant. Now what is the cant deficiency for a speed up to 100 kilometers for the specified gauge? For broad gauge it is 7.6 centimeter. For meter gauge it is 5.1. For narrow gauge it is 3.8. Okay. So when you decrease the cant deficiency from the equilibrium cant which you have calculated in step 1, you will be getting the negative cant. This negative cant, what you are getting, is equal to the maximum super elevation permitted on the main track. That means once you deduct the cant deficiency from the equilibrium cant which you have calculated, you will be getting a negative cant value. Okay. So what value you are getting over there, that value is to be provided on the main track as a super elevation. Then the restricted speed on the curved track is obtained by adding permissible deficiency in maximum cant on the main track and applying the formula for the super elevation. Now in order to find out the restricted speed, what you can do, you have to add this permissible cant deficiency to the maximum cant, and then you have to find out, or you have to apply this onto the formula for super elevation, and then you can find out the speed. So these are the steps being followed. While doing the problem, you understand what steps were clearly mentioned. Okay. Now coming to problem 1, a 5-degree curve diverges from a 3-degree main curve in reverse direction in the layout of a broad gauge yard. If the speed on the branch line is restricted to 35 km per hour, determine the restricted speed on the main line. So here you are given the degree of curve for main curve as well as the branch curve. A 5-degree curve diverges from a 3-degree main curve, means the degree for the main curve is 3 degree and the degree of curve for the branch rail or branch track is 5 degree. Okay. It is also given the layout is a broad gauge yard and the speed which is restricted onto branch line is 35 kilometers. Clear? 35 kilometers is the speed which is restricted on the branch line. Now what you have to do? You have to understand what is the value of, or you have to determine what is the value of the restricted speed on the main line. Okay. Now what you have to do? You understood that the speed which is restricted on the branch line is 35 km per hour. With this restricted speed, you can find out the elevation to be provided. Okay, we know that the super elevation on the branch line can be found out by the equation E is equal to GV square by 1.27 R. That is to be found out first. So let us see. Since it is a broad gauge track, you know G value will be 1.676. V is given as 35. So 35 square means 35 into 35 divided by 1.27 R. So since you are calculating the super elevation for branch line, you will be finding out the radius r, that is radius of curve. Equation is 1720, that is 1720 divided by the degree of curve. Here the degree of curve for the branch line is 5. So 1720 divided by 5. When you are applying this, you can find out the cant for the branch line. Okay. So let's see what is the value of cant. When you are putting all the values, you will be getting a value of 4.71 centimeters. Okay. So what is this 4.71 centimeters? The maximum speed, when you are providing a maximum speed, maximum permissible speed is given as 35 km per hour. So for that speed, this is the value of super elevation which is to be provided. As per the procedure, negative cant can be found out by subtracting the value of cant deficiency from equilibrium cant. Okay, I'll tell you what is the logic behind this. We know that the cant deficiency is equal to theoretical cant minus actual cant. Theoretical cant is the cant or super elevation which we provide for the maximum permissible speed. Clear? Now, in order to understand what is the actual cant to be provided on the branch line, what we do? From theoretical cant, we can subtract the cant deficiency. So here the theoretical cant value is what? 4.71, because this value has been calculated as per the restricted speed or maximum permissible speed. So the value 4.71 is the theoretical cant over here. When you subtract the value of cant deficiency from this value, you will be getting the elevation to be provided in the branch line. So you can understand now from here, the equilibrium cant value is 4.71, cant deficiency value is 7.60. When you subtract this value, you will be getting a negative value, and that is minus 2.89. This is the cant to be provided in the branch track. So before itself, I have told you that it is not the super elevation what we provide a negative super elevation. So that is the reason you are having minus 2.89 on the branch line. So what is the value of cant you are providing for the branch line? That magnitude itself we have to provide as a maximum permissible super elevation on the main track. So since you are providing minus 2.89 centimeters on the branch line, the value of super elevation to be provided on the main track will be 2.89. Okay. So this is the super elevation actually to be provided on the main track, and this is a negative super elevation to be provided on the branch track. Okay. Now you have to understand, or now you have to find out the maximum speed which is to be allowed on the main track. That is our question. So what you have to do? Maximum permissible speed can be calculated once you know the theoretical super elevation. How can you find out the theoretical super elevation? You know cant deficiency is equal to theoretical cant minus actual cant. Okay. So theoretical super elevation can be found out by cant deficiency plus the actual cant provided. The actual cant provided is 2.89. The cant deficiency is 7.6. So when you add up, you will be getting the value 10.49. This is the value for theoretical super elevation on the main line. So once you have got the theoretical super elevation, now you can find out the speed of the main track. That is the maximum permissible or the restricted speed on the main track from the equation E is equal to GV square by 1.27 R. Okay. In the question it is given that the radius can be found out by putting a value of 3 degree because it is 3 degree curve for the main track. Okay. So 1720 by 3 when you give, you will be getting the value for the radius. Substitute 1.676 as the G value. V is to be found out 1.27 into 1720 by 3. Just calculate the value. You will be getting V square is equal to 4557 km per hour. When you take the square root, you will be getting 67.5 km per hour. This is the restricted speed on the main track. Okay.